All right, this lecture is on various objections to the deductive nomological model of scientific explanation. If you haven't already watched the lecture on the DN model, I suggest you watch that first. This is mostly based on the article by Scriven, but there are a few other things that aren't in the Scriven. They do appear in the Stanford Encyclopedia article as well. So, as you may recall, Hempel and Oppenheim, they start out by trying to define roughly what we mean by scientific explanation. And one of the things they do is they say that explanations are answers to why questions. And right off the bat, Scriven goes after that. He says, look, just being the answer to a why question, pretty inadequate way to sort of narrow down what you're talking about. First of all, there's lots of scientific explanations that aren't answers to why questions, right? If I were to answer the question, how do airplanes fly? That would be a scientific explanation. Or what is it about brains that makes them capable of thought, right? If you answered this, you would have given me a scientific explanation, but it's not a why question. So it seems like just the grammar of like how the question is asked seems sort of irrelevant, right, to whether the answer counts as an explanation. And you'll recall that Hempel and Oppenheim make a distinction between explanation and mere description, right? Explanation is supposed to be something more than just describing the phenomenon. Scriven's not so sure about this either. So if you read the Hempel and Oppenheim, they give you a little example of a scientific explanation sort of at the beginning. And Scriven points out that really what all they've given you is a description of a kind, right? So here's the whole quote from Hempel and Oppenheim. A mercury thermometer is rapidly immersed in hot water. There occurs a temporary drop of the mercury column, which is followed by a swift rise. Increase in temperature affects at first only the glass tube of the thermometer. It expands and thus provides a larger space for the mercury inside. The surface therefore drops. As soon as, by heat conduction, the rise in temperature reaches the mercury, however, the latter expands. As its coefficient of expansion is considerably larger than that of the glass, a mercury rise results. So this is supposed to be an explanation of what goes on when you dunk a mercury thermometer in hot water. I think I actually have a picture of ice water there, but I couldn't find a picture of hot water. It sort of looks like maybe rapidly boiling water, right? So Scriven's point is like, is that an explanation or a description? It could be either. They're just describing a lot of things that happen in sequence, right? And, you know, they do use words like thus and therefore, which maybe indicates, right, if you'll recall, Hempel and Oppenheim think that a is an argument, right? And thus and therefore tend to be words you use when you're introducing the conclusion of your argument or something. But anyways, this isn't clear at all that this is some sort of deductively valid argument in the way Hempel and Oppenheim require. So Scriven thinks the better thing to say about the relationship between description and explanation is that some descriptions are also explanations, right? And some aren't. The example we used in the last lecture of a description that wouldn't be an explanation is if I wanted to explain why objects fall down rather than up. And all I did was just list the various objects that fall, right? Goats fall down, staplers fall down, helium balloons go up, and so on. I would be describing the phenomenon in detail, but I wouldn't be explaining it, right? So some descriptions don't seem to be explanations. Some of them seem to be explanations. So Scriven's point is, what's the right kind of a description, right, that counts as an explanation? It's going to be the ones that fill some gap in your understanding. Which sounds right, but the downside to that potentially is that now whether a certain description counts as an explanation is going to depend on sort of who you're talking to and what their understanding is and what sort of gaps they have, right? So it becomes a very contextual kind of relative thing. So moving on, Scriven also wants to poke holes in the idea of the relationship between explanation and prediction. Recall that Hempel and Oppenheim, uh, they say explanation and prediction are basically two sides of the same coin. So it's just sort of happens. It's just a pragmatic distinction, they say, between like when whether the explanation happens before or after the phenomenon that's being explained. If it happens before, it's prediction. If it happens after, then it's not. But Scriven says no. There's much more differences between explanations and predictions one Oppenheim uh, allow for. So first of all, you can predict without explaining. In other words, predicting is not sufficient for explanation. Right? It can't be the same thing. So here's his example. You may notice that uh, with regularity, when cows lie down in the field during the day, it rains within a few hours, right? So suppose you observe something like that. That would certainly allow you to predict rain with very good accuracy, but I don't imagine you'd be able to offer anything like an explanation of why it's raining. Right? It's just a correlation. Correlations do allow for predictions, right? But they're not the same thing as explanations. Explanation is definitely more than prediction. What more? Well, it's understanding, right? You understand the phenomenon. Whereas prediction is just describing an event before it happens. And the wrong kind of describing we're talking about here, not the kind that counts as explanation, really just an identifying description of a phenomenon, right? It will rain. Okay. And the other way around, you can explain without predicting, right? So this shows that prediction is not necessary for explanation. Um, Outside of the sciences, this is pretty common. We did talk about how one kind of explanation I can do in everyday life is explain the symbolism of Moby Dick, right? Right, explain to you the rules of the game of chess. Those aren't scientific explanations, right? And they certainly don't do any predicting. Um, just because you explained to you the rules of the game of chess doesn't mean that you could predict with any accuracy the moves that I would make in a game. Um, but even within science, there is explanation that doesn't count as prediction. So I can explain Newton's theory to you, right, without predicting anything. Um, I could explain a mathematical proof that's involved in physics. I could even explain a mechanism. I could explain how a cell works to you, right? I could describe it. Um, that doesn't necessarily mean that I can predict the behavior of the cell. Okay, so you might worry, wait, well, are we still talking about the same kind of explanation, right? Especially, with Moby Dick symbolism, that's sort of an explanation of the meaning of something. Maybe that's not the same as scientific explanation, but Scriven wants to say, yes, actually it is. What you're doing is filling a gap in understanding, and that's, for Scriven, what explanation counts as. So me explaining Moby Dick is filling a gap in your understanding, and that's explanation. Another objection, right? Hempel and Oppenheim's view is they themselves say that you can explain laws, right? Um, our example was we talked about the explanation of how a pencil appears bent when it's put in water, right? And then we said there are certain laws about the relationship between the index of refraction of the certain substances, but then you might then ask me, well, why is that a law, right? And according to Hempel and Oppenheim, well, I can also explain that law if I can provide premises, right, from which you could deduce that law, which would involve the physics of the substances and of light. Um, but that's not a prediction, right? Laws, it's not like I could make that prediction before the law exists. Laws exist right throughout the universe for all time, so there's no predicting a law. So, sort of even out of their own mouths, Hempel and Oppenheim sort of contradict themselves there. So, in the case of explaining laws, explaining can't be predicted. So Scriven then, if you read it, goes into a long sort of like passage about an example of a bridge collapsing, right? And what's involved in explaining that. And he wants to point out that really what's involved in explaining something like that is far, far less than what Hempel and Oppenheim require. Um, so suppose we do want to understand why a particular bridge collapsed. And we have some information. Maybe we have an eyewitness account that a particular girder was like the first one to break. We have some knowledge about metals, right? How the elasticity will deteriorate over time given certain conditions. A certain weight can be sufficient, right, to make the girder snap. Um, so we take a sample from the girder and we confirm that it's definitely its elasticity had significantly deteriorated. And I think at that point, or Scriven says, we should want to say, okay, we explained the bridge collapse, right? One of the girders had degraded. Um, but we certainly couldn't have produced anything like an accurate prediction, like of when and where the failure would occur, right? Um, and you might look for other potential problems in the bridge. Say you don't find any, right? Um, say there wasn't the case that there was like an extraordinary load, like some big truck that wasn't supposed to be there. Um, so again, you have to conclude, okay, well, that was the cause. The explanation is fatigue in the girder. Um, and really, once again, though, the kind of prediction we could make with that sort of explanation is like only the very weakest, right? We could say maybe, given the state of the particular girder, if we'd known it ahead of time, then any load above a certain threshold, probably a very big one, is likely to make it collapse. Not guaranteed. Um, and probably the range that we'd have to say, and any certainty that it would collapse would be like way higher than the actual load that didn't make it collapse. Um, so this example seems to show that like what counts as a sufficient explanation, right, is just not doesn't have to give us predictions. Right? Usually, perfectly good explanation, if it predicts at all, only like in the really crappiest, weakest sense. So, in general, his point is that a good explanation of an event is just you point out the most likely necessary condition for the event. Um, so, a well-designed bridge could only collapse if there was unusual fatigue in a girder, or like an unusual wind event, or maybe something too large going across it, right? So what you do is you sort of rule out, oh, well, there wasn't like a hurricane or anything that day, and no, there weren't any exceptionally large trucks that drove by it, so I guess it has to be the girder, right? Um, but the thing is, the fatigue in the girder in itself isn't like a sufficient condition. Like you're not guaranteed a bridge collapse if a girder is gotten a little old, right? So it's no good for predicting. Okay, so far Scriven has attacked the concept of explanation is the answer to a why question. The concept of explanation is different than descriptions. The concept of explanation as identical to prediction. Right? He's knocking down Hempel and Oppenheim's points sort of one by one. And maybe you agree with his points, maybe you don't. Right? Um, one thing that the author of the Stanford Encyclopedia article points out is that a lot of Scriven's examples may not count as scientific explanations, right? Depending on what you think that means. Even the bridge collapse thing, maybe not, right? Um, but so now Scriven's going after explanation truth, right? So recall that Hempel and Oppenheim, um, they were a little worried about. They said, well, the premises, right, in the explanans from which you deduce the explanandum, uh, they have to be true. They can't just be well corroborated, right? Because we don't want to say that old theories that have turned out to be false gave us good explanations. Um, but Scriven says, no, I can certainly explain things that aren't true, right? In particular, things that didn't happen. So something like, oh, yeah, well, you were on time for once today, but if you had been late as usual, I know who would have been responsible. It would have been your flaky boyfriend, right? It's always him. He's got some reason to hold you up. Or you might say, someone's borrowing your car. You say, okay, here's the keys. If the car doesn't start, it's probably the battery, so just jiggle the wire, right? And let's say it does start and it's not an issue. But nonetheless, these are good explanations, right? I can explain that if the car doesn't start, I have a good idea of why that might be, right? And even in science, right? So those are everyday explanations. But in science, like in quantum mechanics, right, uh, the sort of forefront of the cutting edge fields where we don't have all the answers, we'll have competing explanations, right? And one of them's got to be false. They can't both be true. Um, and yet we still call them both explanations, right? So this idea that Hempel and Oppenheim have that you have to require the premise of the explanation to be true, like known to be true, seems too strong, right? Because in the end, we never know at a given time whether our theories are true or not, because it happened all through history. Everyone believes a theory, and then it turns out it's false. So um, that would kind of mean that we just never actually have explanations, or never know if we have one, right? Since remember Popper, right? Theories are never proven true; they're only corroborated. Okay, now he's going after explanation as a kind of deduction. Um, so Hempel and Oppenheim, right, their account of explanation is that explanation is a deductive relationship between sentences, right? The sentences in the explanans and the sentence that is the explanandum. But, right, in reality, um, explanations aren't sentences. They're factors and events in the world, right? Laws of nature, things like that. Um, so it's actually kind of odd to describe explanations as deductive relations, because deductive relations only occur among sentences, propositions. Explanations are things in the world. So, strictly speaking, what you might have, to be fair to Hempel and Oppenheim, is you have a deductive relation between the sentences that describe the things in the world. So this is maybe sort of a nitpicky point, an important one. You shouldn't just run around saying explanation is deduction, right? Because actually, no, deduction is relation among sentences, propositions. Explanation is something else, right? Something that happens in the world. Um, okay, the law of nature component, right? So this was the nomological part of the deductive nomological account of explanation. Um, they, Hempel and Oppenheim say, yes, a scientific explanation has to have a law of nature in the explanans, and also it has to be an essential component, right? Get out, the deduction would be invalid. So Scriven has this example that's sort of become sort of famous. You might say, well, imagine I'm just sort of working on, this is back when inkwell, people still used inkwells, I guess. I'm working on a paper and, oh, I knock over an inkwell, with my leg, make a stain on the carpet. Now I want to explain that. What Scriven says is like, can I just say I hit it with my leg? Doesn't that count as an explanation? Do I really need like Newton's laws of motion and gravity and all that stuff? Um, Now we did talk in Hempel about their account was like, if it is an explanation in the scientific sense, it's because there's some implicit invocation of like laws and things like that, right? Remember our example of when my tire blew. In one sense, I could explain my car accident because my tire blew, but in a more stringent sense, right? If you push me, I'd say, okay, well, actually, it's because the air pressure in the tire was beyond a certain point, with relative to the elasticity of the rubber in the tire and so on, so and the force and the direction, the velocity of the car is involved. Um, so for Hempel, everyday explanations are only explanations insofar as they are abbreviated versions of full explanations that do have laws. And Scriven denies this, right? So again, and in the SCP article, Woodward a lot of makes a point of this. Well, maybe there is a difference. Maybe there's two kinds of explanations: everyday ones and scientific ones. And this may be a problem with Scriven's objection there. Okay, so Scriven wants to say a little more about the relationship between explanation and understanding, right? Because remember, he said explanations are kinds of descriptions, but they're ones that fill a gap in a person's understanding. And this was interesting because it's sort of context specific, right, relative to the person and what they understand. Um, so he says explanations. Here's a little bit on. I can narrow down exactly sort of what I mean, right? But what kinds of things are explanations or what are. So here's the ways that explanations can fail to be good. First of all, they can be incorrect, right? They might just be untrue. Right? So if I explain my car accident by talking about gremlins, right? Then that's just an incorrect explanation. Or explanations in the past that explained, right, the kettle boiling because the caloric substance moved from the burner into the through the kettle into the water, right? Um, that's an incorrect explanation. Um, Number two, they can be incomplete if the explanans doesn't actually explain the explanandum. Um, and three, they can be inappropriate if they don't address the relevant gap in understanding. So this number three is sort of the context, um, contextual part, right? So what is the gap that we're trying to address? So that's obviously a contextual matter, but of course, but Scriven says even the incompleteness issue is also sort of contextual, right? So I could, right? So you explain to me why the stapler falls down instead of up, right? You give me a perfectly good explanation using Newton's laws and the mass of the stapler, or the mass of the Earth, the mass of the ceiling and the sun and all that. You do the math for me and you say, here, look, I've explained it for you. And I might say, well, why is the gravitational constant what it is, right? Why is the mass of the stapler what it is, right? You, just like a child, I can keep asking why questions, right? And I can insist that your explanation is incomplete in that sense. Um, but some real way, we have to insist that there is uh, an appropriate level that you can be forced to go back in your explanations, right? At a certain point, it's unfair of me to keep asking why and insist that your explanation is incomplete. Now, that can be context relative, right? So, in the context of a couple of physicists who do want to argue over the gravitational constant, then that could be appropriate, right? But I think it's inappropriate if you're simply trying to explain to me why staplers go down instead of up. Um, so, when is an explanation complete? Well, Scriven says when the thing in question is understood. Um, Maybe a little vague, but maybe that's the best we get, right? Okay, so that's sort of it for Scriven, but there is a little more to say about a well-known objections to the deductive nomological account of scientific explanation. So I want to make sure that you see those as well. So there's this issue of explanatory asymmetry, right? Um, so if explanation is simply a deductive relationship between the conclusion and a a set of premises, um, that doesn't say anything about sort of causal relations, right? And so you can end up uh, things count as explanations that really shouldn't. So, for example, take the height of a flagpole, right, and the height of its shadow. There's a relationship between the position of the sun, right, the height of the flagpole that will determine the length of the shadow of on the ground, right? But that relationship is actually symmetrical, right? I could also derive the height of the flagpole from the position of the sun and the length of the shadow on the ground, right? But you wouldn't want to say that I have explained why the flagpole is the height it is in turn because I've cited the length of the shadow. Um, it's not the shadow that causes the flagpole; it's the flagpole that causes the shadow, right? So this deductive nomological account, you'll recall they didn't kind of want to avoid talking about causation, but that gets them into a pickle because causation is asymmetric; it's kind of one way. Um, Whereas this deductive relationship can be symmetric sometimes, right? Um, so this is a problem, and we will talk about it later. Um, People will try to solve it in some of the essays that we'll read for later in the week. There's also the issue of irrelevant explanations. So suppose it is a law that taking birth control pills makes it unlikely that someone will become pregnant. And I, who have no ovaries, take birth controls and I don't become pregnant. You could certainly, so you could deduce from that law, right, that Nate will not get pregnant if he takes birth control pills. Is that an explanation of why I didn't get pregnant, right? Well, no, the real explanation is that I don't have any ovaries. Um, so the derivation, right, it satisfies the criterion of the deductive nomological model, right? So if you believe Hempel and Oppenheim, apparently that should count as an explanation of why I don't get pregnant, right? This law about birth control pills. Um, but again, what it's missing is that what's the causal, right? What's the causal reason for my lack of pregnancy? And it's my lack of ovaries. It's not my taking birth control pills. So again, there's something that the DN model is not capturing, and it seems to have to do with its inability, or it's not even trying to capture causal relations. So, in summing up, yeah, the DN model definitely has some problems. Um, so, a good paper would be take one of these objections and try and help Hempel and Oppenheim out, right? And try to respond on their behalf and see, no, right? Write a paper saying, uh, Scriven or whoever points out this objection to the DN model, but actually there's a way that the DN model can handle it if we do such and such, right? So that's a good paper. In the next lectures, we'll see some other accounts of explanation that are supposed to try to avoid some of these problems, and of course they will have problems of their own, but that's it.